Hey everybody, I'm Dan Ryan,
And I'm Boris Chabel.
and today we just want to show off our final thesis project for the Royal Military College of Canada using lead motion controllers.
So the aim of our project today was to reduce sensor shadowing, which is a huge issue with lead motion controllers. As you can see in the stock system here, and with our frame using the bottom lead motion controller here, if I put my second hand on top, we can't see what it's doing. Same thing sideways, if I move my thumb, we can barely see the motions. That's the sensor shadowing, that's the issue we're trying to solve. So the first thing we were going to talk about is our frame. Our frame is able to host 4 lead motion controllers, which are all attached to 4 different computers in our distributed system. The idea was that the more lead motion controllers we had, the more sensors we had, and the more we were able to reduce sensor shadowing that way and cover more hand gestures. So for our frame design, we made a thin metallic frame with the controllers that were protruding a bit on the inside. We want to do that because there's the issue of IR reflection that happens within a wooden frame, let's say. We're getting a lot of reflection from the IR lighting bouncing around, and we're not getting the data we wanted to. So this thin frame was able to get rid of that issue, and we put a black base here to reduce the IR reflection from the table for the top lead motion controller. We're going to talk about the relay modules next. So all these computers have a relay software on it, and what the relay software does is it does a calibration routine, and once that's done, we can see on the right lead motion controller here that the stock visualizer is showing the hand. My hand right now is sideways, but the lead motion controller is showing it as if it was on a table. And what we want to do is we want to rotate it, which we can see on the right visualizer. And what that does is it puts all our four relay softwares, they put all our lead motions in the same frame of reference.
So at this point we want to send all of the data over to our Leap Fusion computer, which is over here. So all the data from each of the relays gets amalgamated on this side, and we're going to use all the data there to come up with the best representation of the hand. The way we do that was we choose the 2 best representations of the hand. We do an iterative closest point fusion formula to find the best data representation of that hand. We then put it out in the visualizer so we can see what we do in the end. So as you can see here, the left screen shows all the raw data coming from all 4 relay computers, and the right side shows our fused hand. So we're using the 2 best representations of the hand to come up with the fused model. So the first movement we'll show is when we completely obscure a hand by moving another one over top of it. As you can see on the base leap motion, the top hand is not visualized whatsoever, and on ours, we show the second hand visualized consistently throughout the motion. The next motion we show is when the hands turn perpendicular and the thumb articulates movement. On the base leap motion controller, we see that it has a difficult time representing the hand, consistently loses the hand or misrepresents it. On our system, we show that the movement is accurately represented throughout all ranges of motion, and the hand is consistently represented. We also have the case of an inverted pinching hand, where a hand is placed in the frame facing upwards and is pinching. And in the base model, the lead motion fails to even recognize there's a hand there, let alone a pinching representation. And in our version, we show that pinching motion occurring. Finally, there is hand interaction, where we have 2 hands in the frame, and they actually interact. As you can see in the base model, it has a difficult time even detecting that there are 2 hands occurring, let alone interacting. In our model, however, we show the accurate representation of the 2 hands and the touching of the 2 fingers. So that's our system. We hope you guys enjoyed it, and I hope it gives you some ideas for what lead motion can do. And thanks for everything.
Thanks.